So, welcome back, YouTube viewers. As promised in my blog, I'm going to post this new series of video which will consist the introduction part about physical chemistry, and the first phase of this video is actually an introduction to the quantum mechanics, the quantum world. This is generally considered for the high school level, so don't expect any above that, like I'm to say, not for the university level or anything like that, just for the high school students. So the first thing, every high school students when first introduce the quantum mechanics thing, what do you mean by quantums? So let us think it in a more specific way. Now, what is the specific way of talking? By specific way, I mean that if somebody asks me to define quantum in a more generalized manner, how would I explain it? I will say that quantum is in fact the minimum available quantity or the smallest individual part okay. So you will be thinking that what is the meaning of this thing. Okay, so let's take an example. Suppose you are going to any online shop. So when you go to any online shop, they are telling you that minimum quantity, and they will say that suppose one, you have to purchase at least one item. You are going to buy a gaming console, and the minimum quantity is one. Here, this is the quantum of the gaming console that you are supposed to buy. What I mean is that this is the smallest available part for you to select. You cannot go less than this value. In physical world, the same thing is true. By the term quantum, we mean the smallest individual part available to you in a particular dynamic condition. Now that's what do you mean by quantum. But what do you mean by quantum numbers? Quantum numbers are individual numbers that we use in wave mechanics, in physical chemistry, to give a value, a set of numerical value, which will give a particular acceptable numerical solutions of Schrödinger wave equation or any other dynamical value function giving set of properties associated with that. Now, quantum mechanics define quantum numbers in various ways using various operators. We have a few operators in which we use Schrodinger's quantum number is very famous, the Schrödinger wave equation. And another very interesting use was found in the Hamilton operator, the energy operator. Now, what this quantum number denotes, they can denote anything ranging from the probability of finding an electron. So it can be like the probability of how you can find an electron in a given system space, or it can denote you the velocity. It can even denote you the energy. All of these values can be determined relatively from our very famous scientist Niels Bohr, who has given few postulates about atomic theories, and from the derivation from Niels Bohr's theory you can find all these values. Anyhow, the next part will be what are the quantum numbers associated with it.